So again, C2 is the second and final. This is where we stop with the prereq chapter. Now we get into like the actual physical chapter 1. Points in a graph. This is again some basic stuff. If a point's on the graph, when you plug it into the equation, the result is a balanced equation. So if the question is this point on the graph, or does this graph pass through the point, then you can simply plug that point into the equation. And if the left side equals the right hand side, then you know it's a yes, and if it's not, then it's a no. So that might look something like this. Determine whether the given points are on the graph of the equation. And the equation is x squared plus xy plus y squared equals 4. And there are 2 points there. So you would plug them each in separately. First we'll test 0, -2. So 0 goes everywhere there's an x, and -2 goes everywhere there's a y. Ah, perfect. I actually don't want you to have the second one. I think you understand it after the first thing, and that's a waste of time. Okay, so 0 squared plus 0 times -2 plus -2 squared equals 4. And I get 0 plus 0 plus 4 equals 4. Does 4 equal 4? Yes. So this is on the graph of that equation. If the left side did not equal the right side, we would say no. Again, like yesterday's first example, not a quiz or test question, but the point of this is to say that you can always check these answers. If you were given points, you can plug them back into check. If you're looking at a graph, you can make sure that you did it correctly by plugging points in from that graph. Questions so far? All right, now we're going to sketch graphs of equations. Now these could be lines, these could be parabolas, these could be circles. Okay, so these are going to be all sorts. They literally could be graphs that you're familiar with, and they could also be graphs that you've never graphed before. So it goes back to the basics of how would I graph something if I didn't know what it was. So one thing is, if it's possible, we're going to rewrite the equation so that one of the variables is isolated on one side of the equation. If you're going to use your graphing utility, this needs to be a y equals scenario. So if I'm going to use the graphing calculator to check my graph, then I have to isolate the y. Second is making a table of values showing several solution points, meaning literally use a t-chart. If you have no idea what a graph looks like, start with a t-chart. And I would say start with things like -1, 0, and 1. You might have to add to those points. You might have to shift in one direction or another if your graph does not exist in that area. But it's a good place to start if you have nowhere else to start. Third, plot those points in the rectangular coordinate system. And 4, connect the points with a smooth curve or a line. When we get into, oh goodness, I think it's 1.3 or 1.4, we're going to go over the general types of graphs you need to know. Parabola, obviously lines, parabolas, cubic functions, those kinds of things. And with those, we will do square roots, absolute value. And with those, we will do transformations, like slide it right, slide it left, shift it up, shift it down, flip it upside down. That's what we'll do when we get there. We'll review all that. For right now, you don't need to use transformations. You're going to try to figure it out by using just like the basic skills of graphing, okay? All right, so example 2 says use the t-chart. In this case, it literally gave you the x values to plug it in. We can go back to A and talk about a different way to graph that. But for this example, we're going to literally use the t-chart. So I'm going to take and plug in each of those. -3 times -1 plus 1 would be 3 plus 1, which is 4. -3 times 0 plus 1 would be 0 plus 1, which is 1. -3 times 1 plus 1, -3 plus 1, which is -2. And -3 times 2 plus 1, -6 plus 1, which is -4. Oh, did I do something wrong?
6 plus 1 is
Thank you. This is -5. So then the last row is just your coordinate. So at -1, we're going to do 4. At 0, we're going to do 1. At 1, we're going to do -2. And at 2, we're going to do -5. Yeah, sure. -1, 4, 0, 1, 1, -2, and 2, -5. So based on prior knowledge, we should have known that this was a line. And like I said in 1-1, we're going to focus more on just linear functions and graphs. So we could have also used the y-intercept and the slope to graph this line. But this section is going to involve all sorts of different types of graphs. So that, again, the t-chart's like your fallback. All right, you do B. Plot those points. Draw the graph, connect them. All right, so these are the coordinate points you should have gotten: -1, -1, 0, 0, 1, 3, and 2, 8. If you look at this equation, and obviously we've all made it through Algebra 2, but if you looked at that equation, what would you have thought this graph is supposed to look like? It's supposed to be a parabola, right? The points that we have found do not technically go down and then come back up again. At this point in your knowledge base, it's okay to literally just connect the points that are there. When we get into quadratics, then I expect you to be like, that's a parabola. I need it to come back up. I'm going to keep plugging in points to the left-hand side, okay? But if I gave you those set coordinate points on your homework or on whatever it is, then literally all you need to do is plot those points, okay? At this point, that's where we're at. Again, when we get into quadratics and we're spending a chunk of time in quadratics, then we would need to know that there's more to it. All right, intercepts. This is what's next for you, right? I think I tried to, yeah, okay. I was like, I know I tried to rearrange them, but again, review, hopefully. Any graph, doesn't matter what the shape of it is, to find the x-intercepts, we're going to plug 0 in for y, so in the opposite letter, and then we'll find the corresponding x. And this is the point where it crosses the x-axis. Depending on the type of graph, there might be more than one of these. There also might not be any of these. If it's a parabola that sits above the x-axis and points up, it's never going to cross the x-axis. So the answers here don't always have to be 1 point. It could be none, 1, or more than 1, okay? Could be intercepts. Same for y-intercepts. For y-intercepts, we plug 0 in for x, and there is no rule on how many y-intercepts something could have, because you might have a square root function that starts to the right of your y-axis and points to the right, never crosses through. If there exists a y-intercept, then that's the point where it crosses the y-axis on your graph. I'm hoping to have... Okay, so we're going to go to our graphing utility. The goal here is to find the x-intercepts and the y-intercepts, and then find the value of y when x is 3.5. It says round your answers to 3 decimal places. I think I said it the other day, but I'm going to say it every time we do something to a rounding. In here, you always round to 3 decimal places. Unless it's something like money, like how many dollars. Obviously, we're not going to say I have $5 and 2.3567 cents. Like, that doesn't make any sense, okay? But other than that, you will always round to 3 decimal places. Okay, first of all, because we've zoomed in so much, we lost the zeros on the left and the right. So you have to pay attention to that. On your quiz, I'm going to give you a little X, Y coordinate plane that you can kind of hand draw and estimate your graph. It is not worth points. It is simply for you to remember what your overall shape looks like, okay? And then if you get something wrong and I give you back your quiz, you're going to be like, that does not look like what it's supposed to look like. Now we know why we got things wrong, okay? But it's not worth points. But if I had started out by doing that, then I would remember there's more than just these zeros. There are these zeros, but there's more than just these zeros, okay? Now, if I want to go back to my initial window, and this is what I would say your standard window is, -10 to 10 and -10 to 10 on both x and y. So negative has to be this negative because it's leading. -10 to 10, -10 to 10. You could also reset your calculators. 2nd plus 7, 1, 2, you're going to hear from me about 15 times this year because we're going to do it every time we use a calculator. But that's how you reset your calculator. All right, now we're back to our general shape. Yes? The other way to see your zeros or how many there are is by using the trace feature. If I click trace, that little spider-ish thing pops up. And if I arrow left or right, what happens on the bottom is I'm going to see the point values change. If I go all the way to the left first, so if I start all the way here, now watch my y values. How do I know if it's an x-intercept? y is 0. So it's going to have to change from negative to positive, positive to negative, negative to positive in order to know it crosses the x-axis, right? So my y is negative. This is obvious, right? There's an obvious one here. Negative. Now it becomes positive. I have passed my first 0. That's 1. We're going to go back and find it, but that's how I know there's 1 there. Now if I keep going to the right, my y is positive, 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 and it just changed to negative, which means I crossed the x-axis there. There's a 0 there. Watch your y. It's going to go back up, hits 0. There's a 0 there. It's going to go positive. It's going to go back negative. I know there's another 0 there. And then it's going to go down. It's negative, negative, negative. And it's going to change to positive. There's another 0 there. So there's 5. It changed 5 times. That's how I know how many zeros there are, even if it's hard to see. If your y changes from negative to positive on that graph, then there was a 0 in between. Does that make sense? Okay, so now we're going to find all those little guys. And the way we do that is we go second trace. This is probably the most important menu on your graph, on your calculator. It is for sure for graphing. This has value, 0, min, max, intersect. We're going to use everything by the end of the year. Today we're going to do value and 0. So a 0 is the same thing as an x-intercept. Those mean the same thing. 0, root, solution, intercept, x-intercept, all the same thing, okay? So I go to 0. You can either arrow down or you can hit the number 2, which right now is not a big deal. But when we get to a menu that you want to go to number 9, it's easier to hit the number 9 than it is to arrow down to the 9th thing. Does that make sense? Okay, so I'm going to go to 0. I'm going to hit enter. What's the question on the bottom? Left bound. Left bound means I have to go left of the 0 I'm trying to find. I'm going to go in order from left to right so we don't miss anything. So I'm going to take my little spider and I'm going to go all the way to the left. As long as it is left of that 0, it doesn't matter how low I go. It has to just be left of it. I'm going to hit enter. Now it asks right. I have to go past where it crosses the x-axis so that it is now right of my 0. I know it because it's now a positive y, right? I'm above it, which means that would be to the right in this case. I'm going to hit enter. Now what does it ask? Are you ready for me to guess? Yep, I'm ready. I'm going to hit enter. And it's going to bring you to that coordinate point. Now what if it's an x-intercept, what should y be? 0. Yes? Is that 0? What does it say? Negative 5.19 e to the negative 13th. Do you know what that means? What? There's 13 zeros in front of that 5. This is scientific notation. So that number is so teeny tiny, it doesn't know what to do with it. It puts it in scientific notation, okay? If I had a round 0.000000000, I've lost count, 513, what's that going to round to? 0. This is a 0, okay? So that's my first 0. Which was negative 3.1129, and we're going to round to 3 decimal places, which means this is good, negative 3.113. Then I go to the next 0. Second, trace, 0. Now I want to go left of the next one. So I have to go past the first one. Anywhere on this little curve before it crosses the x-axis is fine. Anywhere up here because it is left of my second 0. I hit enter. Now I need to go right. And this one, we're not zoomed in enough this time, so it's a little bit harder to see. I'm looking for the y to change sign, right? I need it to go negative. So I'm going. And there it's negative. I have passed the 0. I am now to the right. I hit enter. Guess? Yep, take me there. This time it's true 0. And my point would be what? Good. Negative 0.556. And then I do it again. Second trace, 0. Look where your coordinate points are. I'm at negative 0.6 and 0.1 whatever. So I need to cross it so that it's negative. That's left of it. And then I want to go positive. So I'm waiting for my y to change signs to go positive. It actually hits the x-axis at 0, 0, which tells you what? 0, 0 is the origin. If this guy crosses through 0, 0, then 0 is a x-intercept and a y-intercept. So I just found my y-intercept too. If you keep going, I'm going to hit enter because I just want it. It'll bring me right back to that 0. So I have another one at 0. And I keep going. Second, trace, 0. Now I want to go past the 0. I'm above the x-axis now. I hit enter. I want to cross through to go below the x-axis. As soon as it goes negative, I know I'm there. Hit enter. 0.556. Positive is my fourth 0. And I got one more. Second, trace, 0. I want to go anywhere left of where it's going to cross through that last time, which is that. And anywhere right of where it crosses through. And there's my final 0. The y is weird again. There would be 13 zeros in there. That's going to be 0. And my x is 3.1129, which was the 3.113 we rounded to. Questions? I promise you their quiz is not going to have this many zeros, but it does have multiples, so you need to make sure you know how to find them, okay? And eventually we could get here. So you need to make sure you're really comfortable with the graphing calculator. You don't want the calculator to be the thing that throws you off. All right, so we found our zeros, right? We also found our y-intercept. Let's say 0, 0 was not our y-intercept. The easiest way to find the y-intercept is typically just to trace it and wait for the x to become 0. So I could just trace it this way. There, my x is 0, and I have a y, okay? You can also use the table feature. So second graph takes you to the table feature, and you could use this to find where your x is 0. That would be your y-intercept. Now, depending on your settings, you will see fractions, you will see decimals, or there's a way to alter it, which I'll teach you later, but you will only see whole numbers. And if you only see whole numbers, if your y-intercept's not a whole number, you won't see it. That's where the trace comes in, okay? All right, now the last thing I asked for on that graph was what? What's the direction say? The value of y when x is 3.5. So obviously if I said what's y when x is 3.5, you could plug that in and you could get your answer, right? But easier than that is value. So number 1 says value. If I hit value, it's going to ask you, what value are you trying to find? I'm trying to find the y when x is 3.5. I hit enter, and it's going to give you the y. So if you remember your functions like f of 3, f of 2 on a standardized test, and it gives you this big long polynomial, and you would normally plug that in. If it's on the calculator portion of your test, you could simply type that equation in as your y equals, and then do value, plug in the x, and it will give you the y. So it could save you some work. All right, so now let's talk about format of answers, right? It asks for intercepts. Intercepts are typically in coordinate point form. So for my x-intercepts, they would have been negative 3.1130. They would have been negative 0.5560. They would have been 0, 0. They would have been 0.5560 and 3.1130. If it said zeros, you could just list them, like all the x values. If it said solutions, you could just list them. Intercepts are typically in coordinate point form, okay? Then your y-intercept, 0, 0. And the value of y when x equals 3.5 was just, what was it? 3.566. There were no coordinate point questions on the FRQs on the AP exam, so they didn't have to write anything. Oh, that's not true. There was. But they were specifically like coordinate point. There were no intercept questions. It didn't ask for intercepts. So I stress that they're supposed to be in coordinate point form, but if you had also just given me the x's, I'd probably give it to you too. Should be faster. Symmetry. So I said that last graph actually had symmetry on it because the points were reflected over the y-axis. But there's a couple different ways to determine if something has symmetry, okay? If it's algebraically, so if you have the equation and not the graph of the equation, then how you would determine if it has symmetry are these steps. If it's symmetric with respect to the x-axis, which means I can fold it top to bottom like a hamburger and it will overlap. If that's the case, then you can, if you replace y with negative y, and then you simplify your equation, and it either returns to the original one, returns back to the original one, or every single term has changed signs, then it is symmetric to the x-axis. For the y-axis symmetry, we're doing the opposite. We're plugging in a negative x in place of the x. We're simplifying the equation. If it goes back to the original, or every term is the exact opposite, then it has symmetry to the y-axis. And to the origin, we replace both. X becomes negative x, y becomes negative y. We simplify, and if it goes back to the original, or every term is the exact opposite, then it has symmetry to the origin. Now, you can have origin and y-axis. You can have origin and x-axis. You can have, if you have x and y, you automatically have origin. That's like a circle or something like that, where you could go in all directions. Visually, the x-axis means whatever's on the top would be reflected over the x-axis on the bottom. If it's the y-axis symmetry, whatever happens on the right is going to be reflected over to the left. And then the origin, anything that happens in the top right gets reflected to the bottom left. So something like a cubic function has symmetry to the origin. Something like a y equals negative x line has symmetry to the origin. So top left reflects the bottom, top right to bottom left, or top left to bottom right. Like literally fold it diagonally along the y equals x line. All right, so 4, we're going to put everything together. We're going to graph the equation using intercept, symmetry, and additional points. So the first thing we're going to start with is our intercepts. So how do I find an x-intercept? Make y 0. So I'm going to do 0 equals absolute value of 2 minus x. How do I eliminate an absolute value sign? How do I solve an absolute value equation? Let's say that said 3 equals absolute value of whatever. What do you do? Good. If it was a positive integer, I would split this into 2 equations and set it equal to the positive version of that integer and the negative version of that integer. Okay? So if it said equals 1, I would say that that equation equals 1 and negative 1. I'd get 2 answers. If it equals 0, there's no such thing as positive or negative 0, right? So I literally just disregard the absolute value signs and I continue to solve. And I'd get x equals 2. What if it said absolute value of 2 minus x equals negative 1? Is that possible? It's possible for absolute value to equal a negative number. No. So it wouldn't exist. So y on this graph, y equals negative 1 will not exist. Okay, we'll see it when we graph it. Now I want my y-intercept. What's 0? The x. So y equals absolute value of 2 minus 0. Y equals absolute value of 2. And the absolute value of 2 is 2. No. If it equals 2, we do positive or negative. But if the number's inside the absolute value, it is whatever like the positive version of that number. Yep. Okay, I'm gonna pull in a coordinate plane just so that we can kind of do this accurately. Feel free to be like a nerd like me and put your coordinate grid in your favorites album. And we're going to plot what we already know. So x-intercept is 2, 0. Y-intercept is 0, 2. What does an absolute value graph look like? It's a V of some sort, right? So I only have 1/2 of that happening. I can test for symmetry and use it if it works, which I'll show you in a second. Or I can continue to plug in points, but you have to keep going from here. 2 points is not enough to graph anything. You need at least 3, and you need to know the overall shape, okay? So I did the intercepts. Now let's test for symmetry. So to test for x-axis symmetry, I do what? Make y negative. Now is there, sorry, that's the reverse, 2 minus x. If there was something to simplify from here, I would. So like if that was like a y squared and I plug in a negative y, it's going to go back to positive y. But this does not. Nothing can get simplified from here. So now I compare it. Does that look like my original equation? No, some of it has changed. Has every term changed? Meaning the y changed sign, the 2 changed sign, and the x changed sign? No. So this does not have x-axis symmetry, which means it does not flip this way. Because if it did, then I could do that. Now I test for y-axis symmetry. And to do that, I make my x negative. What happens to 2 minus a negative x? Becomes positive. So now does this look like your original? No. Have all the signs changed? No. Which means it also does not have y-axis symmetry, which tells me this does not happen. So what does that make you think about the shape of this V? Where do we think the other side's going? To the right, okay? What that helps me with is I know if I were to keep plugging in points, like if I don't know what the rest of this graph looks like and I plug in these points, I'm getting nowhere. I'm just getting a line that's going to keep going up on this side. I need to get the other side of this graph. And by knowing that there's no symmetry, it tells me plug in points from this side, okay? If you remember your transformations, if something happens inside the absolute value bars, it means it's shifting left to right. So hopefully that also reminds you that this graph was shifted to the right. But if you don't remember that, and we haven't reviewed it yet, then you're relying on plugging in points. So the last test for symmetry is origin. I'm going to get negative y equals 2 minus a negative x. We already know what happens. I get negative y equals absolute value of 2 plus x. Now, did it go back to the original? No. Are all of them changed? No. 2 of the 3 are changed, right? The y changed, the x changed, but the 2 is the same sign. So there is not origin symmetry either. So now I would plug in points to the right of that 2 and see if it comes back up again. I'm literally going to plug in 3, and that's what it means by additional points. If symmetry gives you enough information to finish out this graph, then you wouldn't have to do additional points. It is only if you don't know what's happening. So I'm going to take and I'm going to make x 3. I'm going to the right of the points I already have. Y equals absolute value of 2 minus 3, absolute value of negative 1, which is 1. And look, it's coming back up again. So I know this graph looks like that. Now let's graph it on your graphing calculator. How do I know what? I just knew I had to go to the right. I could have literally picked any point to the right. Because it didn't have symmetry over here, which means this graph is going to keep rising that way. So I could plug in points over here, but it's just going to keep going high. So I would say the more comfortable you are knowing parent functions, the more work you're going to eliminate for yourself. If you don't know parent functions, you just plug in points in both directions and hope that you figure out your graph. Does that make sense? Okay. All right, so, yeah, Orlina.
The 2 minus x in the,
What color? Give me a color.
green.
Okay.
What we first did.
This one. Oops. This one.
Yeah.
Yeah.
Why did the x become positive?
So when you have an equation set equal to a number and it's not a value inside it, the only time you change whatever's inside your absolute value is when you have gotten it down to a single value. So like if it said absolute value of negative 2, that is 2. But when it is an equation in there, we don't touch what's inside the equation. We solve it by setting it equal to the positive and negative version of the number on the outside. Okay? Yeah.
When does it become two different equations?
If it said something like absolute value equals 1, let's say. Now I would do absolute value equals positive 1, and I would do absolute value equals negative 1.
What if it equals negative 1?
Then it can't exist. That point will not exist.
All right.
Yep. Okay, so go to your graphing calculators because absolute value is in a weird spot. So you do not have absolute value bars. What you have is if you go to y equals, because we're going to type it in, clear out the equation that's there. And then under the math menu, you're going to go over to NUM, second menu, and ABS is your absolute value. All that prior knowledge is going to help you eliminate some work. Watch what happens when we test for symmetry this time. I would plug in, so for y-axis symmetry, I would plug in a negative x. Now I have negative x to an even power. What happens to that negative? It becomes positive, and this becomes 4 minus x squared. Does that look like my original? Yes, so this has y-axis symmetry. If you know your parabolas, that should make sense because the transformations on this, again, I don't expect you to remember all the transformations, but this means it's up 4, and this means it points down. So it's going to look something like that. You would still need to plug in your points. It's going to fail your x-axis symmetry. It's going to fail your origin symmetry. You're going to get 2 zeros or 2 x-intercepts because when I set this equal to 0, I end up getting x squared equals 4. And what do I do to get rid of that square? Square root. And when I square root both sides of an equation, I have to remember to do what? Plus and minus. So my 2 x-intercepts are going to be at negative and positive 2. Questions on that one? Again, if you didn't know, I would go through all the symmetries. You're going to have to find the xy intercepts. You're going to get another y-intercept. In this case, if you understand that it's a parabola that faces down, then those 3 points are enough information to graph it, and you don't have to plug in anything else. If you're unsure, now you're plugging in additional points. And last one. This is a square root. What's the graph of a square root look like? Like the little arc, right? Almost like a little R, okay? And if I know transformations, okay, I know it's a square root, and if I know my transformations, when I add or subtract inside the function, what happens? It goes right or left, opposite direction that your brain says. So if it's a +2, this is a shift left 2. So I know, if I know my transformations, this is a left 2. And again, if you don't know those, it's okay. We're going to review them. If you don't know those, that means you're just plugging in extra points. So my x-intercept here, if I set it equal to 0, how do I get rid of a square root? Square both sides. I get 0 equals x plus 2. Subtract the 2. There's my x-intercept, which is also from transformations. My y-intercept, square root of 2. Not a whole number, so we would approximate that. That's in between square root 1 and square root 4, right? A little bit closer to 1. So we might say this is like a 1.2. Again, total approximation. Does not have to be perfect. When we listed, it would be 0 square root 2. It would stay exact. For symmetry, I would plug in x symmetry. I would plug in a negative y. It does not go back to the original. It does not all change. It fails x-axis symmetry. For y, I would plug in a negative x. It does not go back to the original. It does not all equal the opposite. It would fail y-axis symmetry. and for origin, I plug in a negative y and a negative x, and it fails both those again, so it does not have origin symmetry, which based on my graph makes sense. So in this scenario, you might be plugging in some extra points. If I go left of that -2, I'm going to get something like the square root of a negative number. Does that exist? No, I would know there's no point there, and I'd go the other direction. So like if I plugged in 1, let's say, I'd get square root of 1 plus 2, square root of 3, which is like a 1.7. And we would approximate that. Questions? Okay, tonight's homework has a bunch of graphs on it for you to practice. Do not graph them on your graphing utility first and then do the work. It will give you a false sense of security, okay? Do the work, check them with a graphing utility, that's totally fine. And if you're super frustrated, don't lose sleep over this, you can use your graphing utility. But my advice is to make sure that you know how to do it without, because you are going to get part of your quiz that does not have your calculator, that you have to graph, you have to test for symmetry. And then part of your quiz, you will have the calculator. You'll answer questions like what are the intercepts and what are the values at a specific x. That you'd have your calculator for. On Monday, remember I'm getting pulled out for deployment. I am leaving you the quiz review, and I'll make a video going over the quiz review. I won't do that every time because normally in class I'll answer questions. But I'll do that, and then I'll be here before and after school for help and before school Tuesday. Make sure that we do well on this quiz. This could be a good way to start, okay?